Hello everyone. We are group number 50 from the final year project groups. My name is Vijay Sekara DNM under the registration number 4293. Here we are going to dive into the conference paper which has published under the topic of facial expression recognition using YOLO. Let's have an introduction to the conference paper. This publication belongs to 2023 International Conference on Research Methodologies in Knowledge Management, AI and Telecom Engineering. The research paper was written by 5 authors and affiliated with B.V. Raju Institute of Technology, Telangana, India. There are 17 citations for this conference paper. Next, move on to the next slide. Face is the mirror of our inner state. So, facial expressions can be easily used to understand personal emotions. This facial emotion recognition concept can be used in areas such as human computer interaction, emotion analysis, and social robotics. When it comes to computer workflow, improved user experience is important. So, we can use facial emotion recognition to improve human computer interaction by understanding and responding to changing user emotions. Emotion analysis is crucial in mandatory sectors like healthcare, marketing, and security to get the idea of human emotional state. Ultimately, social robots is rapidly developing area in this digitalized world. For an example, Asimo by Honda. Key aspects of that social robots can be identified as social interaction, emotional connection through AI integration. So, FER plays an important role in social robot development as well. Let's move on to the next slide. According to the conference paper, the researchers have tried to address following outcomes. First one is develop real-time facial emotion recognition system that capable for diverse environments and improve the FAR system's generalization through creating generalized datasets. Other one is achieve accurate and efficient FAR system utilizing minimum resources. The last one is improve the FAR system to perform well on obstructed and unclear faces. So, continue this. Let's continue this presentation with our other group members.
Thank you, Noni. Let's move on to the objectives of this research. There are a total of 5 objectives in this research, and first objective is to develop facial expression recognition system using YOLO framework to detect and classify facial expressions in real time. The second objective is to optimize the YOLO-based facial expression system for efficient and fast processing. Third is to enhance the FAS system to handle various lighting conditions, facial poses, and different facial attributes. Next objective is to compare different YOLO models with various adaptations, modification, and optimal setup with high accuracy. Lastly, evaluate the YOLO framework for benchmark datasets and compare with existing models to demonstrate its performance. Then let's head to the literature review for this research. Mostly focus on three key areas. First key area is deep learning approaches used in FAS systems. Deep learning neural networks has revolutionized the facial expression recognition. Most widely used models among them is convolutional neural networks or CNNs. Is very effective in extracting special features. However, expressions are not static. Therefore, to assess the change over time, recurrent neural network is used. Most popular model among them is LSTM, which is capable of analyzing video sequence and capture temporal dependencies. Current advancement of deep learning model is transformer-based models, such as vision transformers, able to learn global facial feature patterns. Combine facial data with different input data types, such as speech, which can be used to improve accuracy for real-world applications. Next area is YOLO integration in FER systems. YOLO which short for You Only Look Once, is popular real-time object detection algorithm used in facial detection in FAR systems. YOLO is capable of detecting faces and localize them, making it highly efficient. In some studies, high accuracy in FER is obtained through combining different models with YOLO, such as RNN for sequence monitoring and also CNN for classification. Finally, let's look at the gaps in existing FER research. Even with the advancement in technology, there are still major challenges in FER systems. Most datasets which used for training models is limited in diversity, such as representation across age groups, and also models are only capable of classifying basic emotions like happy or sad, but perform poorly in classifying complex expressions like confusion. And also low accuracy is shown in various environment conditions, such as lighting conditions, and handling oscillations is made challenge. Moreover, privacy and ethical concerns are growing, especially in public deployments, due to issues of bias and consent.
Okay, let's talk about the research methodology overview of this research paper. As you know, this research paper is about developing a classification model for emotions of people. Generally, YOLO is used for object detection, but in this research paper, they have used YOLO for face detection, and they have combined the CNN model to use for classification of images. And for the data set, they have used different images for different emotions, and several optimization techniques also were used, and accuracy and real-time inference speed was measured as the performance metrics of the developed algorithm. When talking about the dataset, they have prepared their own dataset by collecting various publicly available data as well as from their friends. This dataset covered diversity in age, gender, and ethnicity, and the image types of this dataset include high resolution and grayscale images. They have verified the labels of these images by using expert human annotators, and this dataset will include 6 emotions, including happy, sad, anger, fear, disgust, and surprise. And for ethical considerations, the collected image data from friends and people they have gathered with the consent of those people, as well as the data is anonymized. After collecting the data, the next step was to pre-process the data to feed the model. As the initial pre-processing step, they have cropped the images to reduce noise, and then some flipping was done in some random images, and the brightness level and contrast level was adjusted in some images randomly. Next, they have splitted the dataset as training, testing, and validation. This training dataset is used for training the YOLO plus CNN classification model, and these validation and testing images are the unseen data for the developed model for measuring accuracies. And then the model architecture and modules they have used. For the initial input module, they have used YOLO model for detecting faces from the dataset they have prepared. Then that extracted frame was sent to the CNN architecture they have developed, and from the hidden layers of that CNN architecture, feature extraction was done, and from the classification layer, the classification was done according to the emotions, according to the 6 emotions. And for the output and visualization, the trained model was used for the unseen data for taking the outputs for different emotions of people, and for the visualization they have included the ROC curve, as well as they have included the loss function as well.
I'm going to talk about training and optimization technique used in the conference paper. The training process began with use of stochastic gradient descent, or SGD, which is widely used optimizer in deep learning. It was configured with learning rate of 0.001 and batch size of 8, which balance conversion speed with training stability. Loss function use is categorical cross entropy, which is ideal for multi-class classification problem. And as mentioned previously, dataset was divided into training, validation, and testing set. Throughout the training, they monitor key performance indicators such as accuracy, loss, and inference speed. Periodically, evaluation were conducted to ensure the model was not just memorizing, but actually learning meaningful facial features. Now let's talk about their results. Their model achieved overall 80% of accuracy in classifying facial expression. This is strong result, especially considering the real-time constraint under which the system operates. The system is capable of accurately recognize 6 primary emotions. They are happiness, sadness, anger, fear, disgust, and surprise. It performs reliable even under challenging conditions such as various lighting conditions and change in head orientation. One of the standout achievements of this work is its real-time processing capability. The YOLO framework allows the system to detect and classify the facial expression within milliseconds, make it highly suitable for applications like human-computer interaction and social robotics. In conclusion, I would like to first start with the strength of their proposed system. The system combines successfully YOLO and CNN architecture to achieve both real-time performance and high accuracy. It's robust under different lighting conditions and various face angles. It also performs well on raw resource system, make it ideal for mobile and embedded use. The key features. The key factor in their success is the use of diverse dataset. The dataset include faces of people from various backgrounds, different ages, genders, and ethnicity, which improve the model ability to generalize across different users. The human verified emotion label further enhance the reliability of the system. At the end, they mention some future works of their project. So, they introduce multimodal fusion such as integrating with audio, text and face, and explore transformer-based model for better sequence understand and future optimized for edge and embedded device. This is the end of our presentation. Thank you.